From not enough to too much. The world's water crisis explained. Many more cities than Cape Town face an uncertain future over water, but there are emerging solutions. By Stephen Leahy. Day Zero. Day Zero, when at least 1 million homes in the city of Cape Town, South Africa will no longer have any running water, was originally scheduled for April 2018. It was recently moved to July. The 3-year-long drought hasn't ended, but severe water rationing, limiting people to a mere 13 gallons, 50 liters per person per day, has made a difference. To put this into perspective, an average U.S. citizen uses 100 gallons, or 375 liters per day. No person in Cape Town should be flushing potable water down a toilet anymore. No one should be showering more than twice a week now, said Helen Zile, the premier of the Western Cape province where Cape Town is located. Like many places in the world, Cape Town and the surrounding region has likely reached peak water, or the limit of how much water can be reasonably taken from an area, says water scientist Peter Glick, president emeritus of the Pacific Institute. Glick, who has spent substantial time in South Africa, says the country generally has good water managers. 2 years ago, I would not have predicted Cape Town would face Day Zero, he said in an interview. However, climate change has disrupted the Earth's hydrological cycle, water cycle, changing when, where, and how much precipitation falls. That has made water management planning far more challenging, he said. Yet our water systems were largely built based on more stable climate of the past. What's happening in Cape Town could happen anywhere, says Glick. Number of months a year region experiences water scarcity, with gray being none to dark red being all 12 months of the year. Global risk. Brazil's Sao Paulo, a megacity of 20 million, faced its own Day Zero in 2015. The city turned off its water supply for 12 hours a day, forcing many businesses and industries to shut down. In 2008, Barcelona, Spain had to import tankers full of fresh water from France. Droughts have also become more frequent, more severe, and affecting more people around the world. 14 of the world's 20 megacities are now experiencing water scarcity or drought conditions. As many as 4 billion people already live in regions that experience severe water stress for at least 1 month of the year, according to a 2016 study in the Journal of Science Advances. Nearly half of those people live in India and China. With populations rising, these stresses will only mount. Disaster data compiled by the UN clearly shows floods are also getting worse. They are happening more frequently, especially in coastal regions and river valleys, affecting more people. Of all major disasters in the world between 1995 and 2015, 90% were weather-related events, such as floods, storms, heat waves, and droughts. Flooding accounted for more than half of all Earth-related disasters, affecting 2.3 billion people and killing 150,000 in that 20-year period. Last year, the costs of extreme weather, floods, droughts, wildfires, storms in the U.S. reached a record-topping $300 billion. These events displaced more than 1 million Americans from their homes. The total freshwater volume consumed or polluted within a country is known as its water footprint of national production. The top 5 countries that contribute to humanity's total water footprint appear below, along with South Africa, where the city of Cape Town is facing a crisis-level water shortage. Water footprint of national production. The total freshwater volume consumed or polluted within a country is known as its water footprint of national production. The top 5 countries that contribute to humanity's total water footprint appear below, along with South Africa, where the city of Cape Town is facing a crisis-level water shortage. Worldwide, total water footprint, 9,087 billion cubic meters per year. The United States uses 1,053 billion cubic meters of water. Russia uses 396 billion cubic meters of water. China uses 1,207 billion cubic meters of water per year. India uses 1,182 billion cubic meters of water per year. South Africa uses 59 billion cubic meters of water per year, and Brazil uses 482 billion cubic meters of water per year. Humanity is facing a growing challenge of too much water in some places and not enough in others. This is being driven not just by climate change, but by population and economic growth and poor water management, experts warn. Water scarcity and flood problems are primarily due to quick growth, increasing vulnerability, and insufficient preparation, says Arjen Hoekstra, a professor of water management at the University of Twente in the Netherlands. Climate change, however, is and will worsen the situation in most cases. The role of embedded water. Cape Town, where nearly 4 million people live, has a dry climate much like Southern California. It is facing its day zero due to increased water demands from population and economic growth in combination with a 3-year drought that severely limited the water supply. Yet what many people don't realize is that the typical home use of water for washing, flushing, and cooking represents only about 3% of humanity's total water consumption, says Hoekstra. Agricultural use uses the lion's share, 89 to 90%, followed by energy production and industry. The Cape Town region is in the heart of South Africa's wine country, which exported 113 million gallons, 428.5 million liters of wine in 2016 to Europe and the US. Yet this export represents a much bigger amount of water that was used to grow and process the grapes. Most of that water is no longer available for human consumption, according to Hoekstra, who is the creator of the water footprint concept. He and colleagues at the Water Footprint Network have worked out that it takes between 26 to 53 gallons, 100 to 200 liters of water to grow the grapes and process them into one 5-ounce, 125 milliliter glass of wine. In other words, the net amount of water used to grow or make something, be it a lemon, cell phone, or glass of wine, is the product's water footprint. Most of the water used to make a typical glass of wine is lost to evaporation, with a small amount stored in the grapes, and the rest is unsuitable for reuse. While the evaporated water will eventually become rain, it is unlikely to fall over the same vineyards or even in the Western Cape province, meaning it is effectively lost to the region. So that means a typical 25-ounce, 750 milliliter bottle of wine has a water footprint of nearly 200 gallons. That means the region's 2016 wine exports involved the net consumption of 113.2 billion gallons, 428.5 billion liters of water. This is water that is lost to the region. This is an example from soda. Many products we use every day have a larger impact on the global water supply than we realize. A single half-liter serving of soda requires up to 175 liters of water to produce. The average water consumption to produce one serving of soda: growing the natural sweetener, 30 liters. Growing coffee beans for caffeine, 53 liters. Processing flavors, 80 liters. Molding a plastic bottle, 5.3 liters. Water added in recipe, half a liter. Manufacturing and packaging, 7 liters. Equals 175 total liters used. South Africa already has 7 million people without access to water. Meeting their needs would require 3.3 billion gallons, 126 billion liters per year, 1/3 of the amount the wine industry consumes. On top of that, the Western Cape exported an estimated 231,000 tons of citrus fruits, mostly oranges, in 2017. The water footprint of one orange, the net amount of water used to grow it, averages 21 gallons or 80 liters. Using that basis, those citrus exports used up 30 billion gallons, 115 billion liters of the province's water. Not only does it take water to grow anything, it also takes water to make most things: cars, furniture, books, electronics, buildings, jewelry, toys, and even electricity. This water, which often goes largely unseen, is often called virtual water. What gets forgotten is that virtual water is as real as the water you drink. South Africa, a water-stressed country, also exports oil products, minerals, and metals, all of which require enormous amounts of water. For example, it exported 211 tons of platinum in 2012. That's like an export of 45 billion gallons, 170 billion liters of water, the estimated amount of water needed to mine and process the metal. Other large countries with growing populations, such as China and India, also export staggering volumes of virtual water, often while facing considerable water scarcity problems at home. This simply can't continue, says Hoekstra. Seeking solutions. All of those exports could be produced using far less water, Hoekstra says. It starts with what he calls the most important waterman strategy: grow and produce things in the right place. In other words, water-intensive crops like rice and cotton should be grown in water-rich regions. In a global economy, drought can be a big issue even in water-rich countries because of growing dependence on imports. Around 38% of the European Union's water consumption is reliant on water availability in other countries to grow soybeans, rice, cotton, and other products that it imports. That makes Europe vulnerable to increasing water scarcity and drought, says Christopher Briggs, executive director of the Water Footprint Network. A coastal city, Cape Town hopes to solve its problem by getting a new water source, the ocean. It is building its first desalination plants. However, these are expensive and energy intensive. Gleich says it would be more cost effective for the region to shift to less water intensive crops and to reuse treated wastewater. Currently, Cape Town reuses just 5% of its treated wastewater compared to Israel's 85%. Israel has also eliminated water-thirsty crops like cotton and made major improvements in water efficiency to free up more water for population growth. California, which recently suffered through 4 years of drought and water restrictions, also needs to shift its agricultural production to less water-using crops, says Gleich, who is based there. And the state could increase its wastewater reuse from the current 15%, using the surplus to recharge depleted aquifers and use on crops. A reservoir can be seen at a low level in Cape Town in February. Many other cities could suffer similar fates in the near future, experts warn.